Hi ladies and gentlemen, this is Mr. Green again. This is another in a series of recordings for geometry. We are working our way through Unit 2. And in Unit 2 what we're doing is looking at different shapes, different objects. We're finding the surface area and the volume of those different objects. What we're looking at today are spheres. Well, what's a sphere? It's a golf ball. It's a baseball. It's any type of a round, circular type object. We're going to look at those in just a minute. Okay, don't forget, make those quiz corrections. Really will help you get your grade up if you're needing a few extra points. Okay, due dates 28 days after the things are due. Your quizzes, your tests, and things like that, they get locked down. So if you're going to make corrections, if you're going to get them made up, get them done in the first 28 days. Don't let it go beyond that. Okay. Surface area and volume of a sphere. Well, I'm going to mix things up a little bit here. We've done surface area every time first. This time I want to do we're going to do the volume first. A little bit different, just changing things around. So for a sphere has a center. Voyage to the center of the sphere. Okay? Center, right there, point P. Through the center, you've got a diameter. That diameter extends straight across the sphere, straight through the sphere. So if you stuck a needle right through a ball and it came out the other side, that would be the diameter of the sphere. Radius goes from the center out to the edge. It's half of the diameter. Not a problem. Okay? So we're going to look at a couple of things here. The volume of a sphere can be demonstrated to be one to be the volume of a cylinder minus the volume of two cones. Now, how can we demonstrate this? If you took these two cones and put them on top of each other, they would extend a little bit above, a little below this, and you'd have to do a little bit of shaving, a little bit of shaping, but it would work out to be to the volume of a sphere. Okay? It's just one of those things where they all work out together. So I'm going to take the formula for volume of a cylinder, and I'm going to subtract from it 2 times the volume of a cone. When I do this subtraction, pulling like variables together and so forth, I wind up developing this formula right here, 4/3 pi r cubed. Now I know it looks a little bit weird, but we've been dealing with thirds already with volume. We had 1/3 and 1/3. Remember those? That was on the pyramid and on the cone. This one just happens to be 4/3 pi r cubed. Really is an easy formula when you think about it because we only have one variable that we're trying to find. It's the radius. So if you use that radius, it's really not a difficult formula at all. 4/3 pi r cubed. Okay? So if I've got a radius of 9, I'm going to take 9 cubed. 9 times 9 times 9, that's 729. Divide it by 3, multiply it by 4, and I wind up with 972 times pi, and that's 3,050 cubic centimeters. Okay? How about this one? 4/3 pi r cubed, diameter 9, half of 9 is 4.5, 4.5 cubed, 91.95. Multiply it times 4, divide it by 3, you get 121.5 times pi, or approximately 3.82 cubic centimeters. Okay? This represents a human eye. It's spherical in shape. The diameter is about 2.5 centimeters. Half of 2.5 centimeters is 1.25 centimeters. Cubed, 1.953. Okay? Times 4 divided by 3, that's 2.6 pi, or approximately 8.2 cubic centimeters. A human eye is approximately 8.2 cubic centimeters in volume. Okay? A golf ball. They tell us that a golf ball could be no more than 1.68 inches in diameter, according to the rules of golf. So if it's that big, half of that is 0.84. 0.84 cubed is 0.5927. Times 4 divided by 3, 0.79 pi. Times 3.14 is 2.5 cubic inches. Okay? That means the volume of a golf ball is no more than 2.5 cubic inches. Okay. Now I'm going to do surface area. Surface area is 4 pi r squared. This is one that you can demonstrate for yourself. Take an orange. Set an orange on a piece of paper and draw a circle around it. And it has to be the exact circumference of the orange, so you want to make certain it's the same size as what you got for the orange. Do that 4 times so that you have 4 circles sitting on the piece of paper. Then peel the orange. Lay the peels as close as you can inside of that circle, filling it as much as you can, and it will fill all 4 circles completely. That's what you're looking at when you're looking at surface area of a sphere. It's 4 times pi r squared. The area of a circle times pi. And that's what you did. You just found a circle 4 times. You found the area of that circle and filled it up with orange peels. So if the radius is 8, 8 squared is 64. 64 times 4 is 256. Times pi is 804 centimeters squared. Here's a sphere. We got a 30 centimeter diameter. That's a 15 centimeter radius. 15 squared is 225. Times 4 is 900 pi. That's 2,830 centimeters cubed. Here's a baseball. A baseball is about 3 inches, about 2.9 inches. And that's the diameter of the ball. They're wanting to know how much leather goes on the outside of the baseball. So you take 1.45, where'd that come from? Half of 2.9. 1.45 squared is 2.1025, times 4 is 8.41, times pi, 26.4 inches squared. I want to let you all know that I do appreciate the fact that you've been here, been sending me information about what course you're in and what section of the course you're in. It really does help me to answer the questions when you send them to me. Okay? And I do appreciate the fact that you're also coming to tutoring. If you need help, please make certain you come to tutoring as often as you need to. I'm there Tuesday, Wednesday, and Thursday. I'm there to answer your questions. Almost through with Unit 2, so we're getting close. You better make certain you got everything taken care of. Talk to you next